Hello everyone. In today's tutorial, we'll be learning about Decision Tree Classifier. So Decision Tree Classifier is the classifier that is used for supervised as well as regression learning. The decision tree is like a tree with nodes. The branches depend on a number of factors. It splits data into branches like these till it achieves a threshold value. A decision tree consists of root nodes, children nodes, leaf nodes. We'll be discussing about the terminologies later in this video. All the data points end up being the leaf nodes. A decision tree is a supervised machine learning algorithm, and as I mentioned, now it is not only used as a supervised, it is not only used as a classification module, but also as regression algorithm. Now, decision tree usually implement exactly the human thinking ability while making a decision. So it is easy to understand. For example, look at the image over here. Now let us think that how would you think if it is sunny, overcast or rain? Would you like to go out for a walk on sunny, rain, overcast? What are the possibilities of the chances of you going out for a walk? Let's say that if you go out on a sunny day and it is humid, then what are the chances that you go on the humid day and you won't go on a humid day? So the pattern of our thinking can be jotted down as a decision tree. The logic behind the decision tree can be easily understood because it shows a flowchart type of architecture, like a tree type of architecture, which makes it easy to visualize and extract information out of the background process. Now, let us discuss the elements of a decision tree. So the different elements are nodes. So all these rectangles that you are seeing are nodes. This is the point where tree splits according to the value of some attribute feature of the data. So these two points that you are seeing is known as simple nodes. Then we have edges. So edges, it directs the outcome of a split to the next node. We can see in the figure like this one. So from this node, we are going to this node. So these all lines that you are seeing are the edges. Then we have the root. This is the node where the first split takes place. So always the head of the tree will be the root node. And thereafter, we have the leaves. These are the terminal nodes that predict the outcome of the decision tree. So as you can see, these two last nodes and this node here is the leaf node. And as we had discussed, leaf nodes are nothing but the data points itself. So the question arises that how should we build a decision tree from scratch? So while building a decision tree, the main thing is to select the best attribute from the total features list of the dataset for the root node as well as the subnodes. So for example, if I have this diagram over here, how did I select that my humidity should be an attribute over here through which the splitting should be done, or windy should be the attribute wherein the splitting should be done, or why is not humidity the root node? So all of these questions pops up, and the answer to this is that the selection of best attribute is achieved with the help of a technique known as attribute selection measure. So with the help of attribute selection measure, we can easily select the best features for the respective nodes of the decision tree. Now, the different techniques for attribute selection measures have been noted down here. First is the information gain, then we have gain ratio, and thereafter we have Gini index. Before moving forward, one should understand the meaning of term entropy. Entropy is used a lot while computing the attribute selection methods. So entropy is the measure of impurity or uncertainty or randomness of the data. So we will get a better idea of the entropy in a further discussion. but entropy the formula for entropy has been given over here. So xi here are the number of classes that we have, like yes or no, windy, humid, sunny. All of these can be the classes, and we are finding the probability of that class multiplied by log to the base of probability of that class. So this is what our entropy is. Let us now understand the very first ASM technique, which is information gain, which is also known as ID3 decision tree. So information gain is the measurement of changes in entropy value after the splitting or segmentation of the data based on the attribute. So it tells us how much information attribute provides us. Following the value of information gain, splitting of the node and decision tree building is being done. So decision tree always tries to maximize the value of information gain, and a node attribute having the highest value of information gain is being split first. So information gain can be calculated as the formula which is being given over here, entropy as we have calculated in this formula, and this is the weighted average. So these are the data points, and this will be the summation of all the data points. So this is the gain that we are finding. Thus, revising the procedure, we will first compute the information provided by required to classify tuples of T, like yes or no. Thereafter, you'll be computing information gain for each attribute, like windy, humidity, etc. Thereafter, you'll be computing the formula, this one, the formula which is given over here. Then attribute is chosen on the basis of information gain. Higher the information gain, greater is the possibility for it to be selected as a node. Now, let us take an example. Imagine that this is the data that has been given to us. Now, the different columns that we have is age, income, student, credit rating. And all these columns are the reason through which we are getting the two classes, whether yes or no, whether the person will buy the computer or not. So what do is we first of all find the information gain of yes and no. So here, if you observe, these are the attributes that we have. We have 14 values, 9 of them is yes, and the rest are no. And that is how the very first thing is being calculated. Thus, we have found out the entropy of the classes. Thereafter, we will be finding entropy for each of these columns. So first of all, we are finding the entropy for the column age. So for the age, this is how we are calculating, wherein this is the weighted average of, here we have 3 different types: youth, middle-aged, senior, right? So we are just adding the number 5 for youth, and how many out of the youth are yes and no. That is the entropy that we are calculating. Thereafter, we are going for middle-aged, and thereafter we are going for senior. After getting this, we are finding the gain of age. So we are subtracting the value that we got over here, which is 0.694 bits, from this value, and the answer that we are getting as 0.246 bits. So this is the kind of table that we have got. In actual sense, you have to find the gain for age, income, student, credit rating, everything, and thereafter you have to compare the gains that you are getting. But since I've already done that, we find out that gain of age is greater over here, and that is how we are getting this tree as the output. And after dividing and splitting age into youth, middle-aged, and senior, we have these as our tables. Now for each of the table that you are seeing over here, we have to again do the whole process of finding the gain. And that is how the whole tree is being made. So I hope this is clear to you. Now, one of the only limitation that this method, which is ID3 decision tree, has is that it is biased towards multivariate attribute. The information gain measure is biased towards tests with many outcomes. That is, it prefers to select attributes having a large number of values. For example, consider an attribute that acts as a unique identifier, such as product ID. A split on product ID, which we have over here, the leftmost column. So a split on product ID would result in large number of partitions, and each one containing just one tuple, because each partition is pure. The information required to classify set D based on the partitioning would be information gain of product of T would be equal to 0. Therefore, the information gain by partitioning of this attribute is maximal. Clearly, such a partitioning is useless, and that is how we come up to our next topic, which is gain ratio, which is also known as C4.5 decision tree. So it applies a kind of normalization to information gain using a split information value defined analogously as info of T. So the computation of gain that you used to do, we'll just keep it as you see the numerator over here. The additional thing that you have to calculate over here is split info. So split info has been calculated as the weighted average and log of the same weighted average. Thereafter, we are dividing it, thus we are normalizing it, and the attribute with maximum gain ratio is selected as the splitting attribute. And thereafter, the same process as we had discussed over here, we calculate for age, income, student, credit rating, then we compare the gain ratio, and thereafter we make the whole tree. The next part that we'll be discussing is Gini ratio, which is also known as CART, as classification and regression tree. So Gini ratio is also being defined as a measure of impurity or purity used while creating a decision tree. An attribute having a low Gini index value should be preferred in contrast to high Gini index ratio. It only creates binary splits. So there will be only and only two values that it can have. As in this example, it is not a binary split, as the split has been done in 3 different tables. But in case of CART, there will be only 2 split. So it is strictly a binary tree. So Gini index can be calculated with the formula which stands over here, where this Pj is for the probability. Next, we'll be moving forward to the code and understanding of the whole math that we have discussed. First of all, we'll be importing all the necessary libraries. So the classifier in Scikit-learn that we'll be using is known as Decision Tree Classifier. We are asking for metrics so as to evaluate our model, then data sets to load iris, then export graphics and pi.plus is used to visualize this tree that we are making. So we are loading our data set. This is how we are splitting it. So the usual way that I always used to split is using the train test split. But this is also one other way of splitting the data, and this should also be known. The first part is using entropy. So entropy here in the criteria in the decision tree means nothing but information gain that we understood the very first time, which is ID3 classifier. So this is our tree that has been made. And as you can see, this is how the whole splitting has been done. The different entropy, sample values, etc., the whole math that we did. Thereafter, we are predicting what our results, what the tree, our model is predicting, and we are finding the accuracy. So our accuracy is 96%. Now the classification report. For if you are unknown with the terms precision, recall, F1 score, and confusion matrix, which we have printed over here, please do go and watch the video which has been given in the description section, wherein I have explained what all these metrics mean. So these are the precision. As we can understand, there is one misclassification here, and there are two misclassifications here. Next, we'll be using Gini index. So Here we are keeping the criteria as Gini, and we are fitting our X train and Y train values. Then the same procedure, we are predicting of how it is giving us the output. Here also we are getting the accuracy score of 96%. This is our classification report. This is our confusion matrix. Now, what if I give a unknown value to it? Then what will it predict to me? So it is predicting me 1, which is the iris versicolor, right? So this is what the whole thing is. I would even like to show you the documentation for the same. Just press Shift Tab and press on this arrow. This is the whole documentation. These are the different parameters such as criteria. It has Gini and entropy, and default is Gini. Thereafter, we have splitter. Then we have max depth of the tree. Then min samples of the leaves and the random state, max leaf nodes, impurity decrease, which is our entropy, and impurity split, class weights. So these are various parameters that it has, and this is one of the examples that they have shown over here. So that's all for today. Thank you.